Hello YouTube, XCT here. Today we are solving Pivotapi, a 50-point Windows machine on HackTheBox that involves some reverse engineering, MSSQL, and Active Directory attacks like Kerberoasting, ASREPRoasting, and various misconfigurations. At the end, we will explore some unintended ways to root this machine. So as always, we start by looking at the port scan. There's SSH, we have FTP. Other than that, it looks like a domain controller. Nothing special here. One thing we also have is MSSQL on the external interface, so that's interesting. Okay, we gotta start with something, so let's go start with FTP here. Just going to use anonymous logon. Now we change to passive mode because there's a firewall on the box, and if you just try to list the directory, it will hang. Now it works. We want to download all these files, so switch to binary. Disable the prompt and just get them all. All right. Let's look at this README file. It's telling us to use binary download. We did that, so we don't have to do it anymore. And now we can look at the documents, but they don't really help with the box. One thing you can, however, do is we can use EXIF tool to check the meta information, especially the author. And if you do it like that, you will see that there's one user here called carorts or something like that. And we also get the domain name. So as far as Active Directory attacks go, if you only have a username, one thing you can try is ASREPRoasting. And this is what we're going to do. So let's echo that username into users.txt file. And then we use impackets get npusers.py, which is executing the ASREPRoasting attack. We give it a users file. We want the output John format, and this should be it. Let's run it. Not much output here. Let's see. Now we got this asrep.hash file here, and we indeed got the hash of this user. So what this means is that this user had a flag set to not require pre-authentication. This is not default, but sometimes accounted in the real world, and we got lucky in this case. So let's try to crack that. And we indeed get a password here, which is this one. So now with these credentials, we can check if we have any SMB shares we can access. Just like that, we give it the host name, the username, the password, and the domain. And we get a few shares here, but there's nothing too special. But one thing that's always interesting is to look through the SYSVOL share, because every user has access, and sometimes there are scripts in it and so on, right? So let's do that. All right, we can access it. Let's look around. Scripts folder, like I said, always interesting. And there's a help desk folder here, which is definitely not default. And we get a few messages here. So let's get all these files. mget. Here we go. So there is an executable and two message files. To convert these message files, we can use message convert. So let's just convert all of them. Now there should be some EML files here, which are readable for us. So let's cut that one. Yeah, and there's this large blob here. So let's just use less here. Now we can read it. Okay, it's telling us that some Oracle database was changed to the MSSQL instead. So let's save that. And this program we just saw, resetService.exe, was created to log in. So this is kind of hinting at that there might be some credentials. And also from the recipient here, we can see another username. Let's save that one as well. There was one more, I think. This WinRM file here. Yep. Okay, here it's telling us that there are some strict firewall rules, and even WinRM is blocked from the outside. So let's save that as well. All right, and then there's the executable. Can use strings on it, I guess. But it's not really giving us anything interesting. So we will probably have to analyze that one in a proper Windows VM, and this is exactly what we're going to do. So I copied over the binary to my Windows VM, and we are going to do some dynamic analysis just because it's the easiest way in my opinion. So let's start Procmon here. And we're going to filter for processes that contain the name Oracle, because the binary is called like that, right? All right, let's just run it now. Stop the capture, and we're going to see if we can find anything interesting here. If you scroll pretty much to the end, you will see that this actually created a BUT file. So let's have a look at this file. But here in the temp directory, there is nothing. This file must be deleted again. So maybe we can catch it if we run it. But we can't see it here. The way I solved this, I basically just removed the delete permission from my own user. So if you run the binary, it wouldn't be allowed to delete the file after creating it, right? So we go here, advanced. You have to disable inheritance, otherwise you can't change it. And then you go to edit, advanced permissions, and we can remove the delete permissions here. So let's do that. And now it shouldn't be able to delete it. And this indeed worked. We can see the files now because it couldn't delete them. Now let's have a look at the script here. I'm just going to do edit here. It's comparing a couple usernames, so we know a few more now. And then it's piping some huge base 64 encoded thing into oracle.txt. And in the end, it's basically just decoding this and writing it to a file. So that looks good. We could probably just run that, but we don't want to execute it before analyzing it, and we don't want to delete these files. So let's just delete the rest here. And if we go back to the start, it kind of looks like it wouldn't decode it if it weren't one of these users. So let's just put our user here. Then we should be able to just run it. And it should write the file to program data. And now here in program data, we can see that this file was indeed written, but it was only the PowerShell script. And I can explain that in a second. Let's just look at it first. And even this doesn't work. And the reason is that we basically removed the delete permissions from the temp directory, and this is something PowerShell really doesn't like. So we have to give these permissions back first. So now we can run this again. And now we actually get the executable. Before we didn't get it because PowerShell can't start with delete removed from the temp folder. So there's another binary. And the way we are going to analyze that one, we are not using Procmon this time. We could, but you wouldn't see anything. We are going to use API Monitor, which is a really great tool. Here on the left, we can basically tell it what we want to monitor. And we can just tick all of these boxes to monitor everything the tool can. And then we tell it which program to run. And we use this restart-service.exe we just unpacked and run it. And it's basically tracing the program execution, monitoring and logging all API calls and stuff like that. So now we got a huge list of things that happened here. And if we look manually, it's just too many things. So let's just see with the search function if we can find a password here, right? And there indeed is one. Here we go. Can copy that, paste it here, and here we go. We got the password, which is Oracle Service 2010. Now remember that MSSQL was open on the external interface, so we should be able to connect. One thing we can use for connecting is MSSQL client from Impacket, and we're going to use that one. It needs the username, which is in this case Service Oracle. Let me give it the password. And it's not letting us connect. If we go back a bit to these hints we got at the beginning, it's telling us that Oracle had problems and they're now using MSSQL. So maybe they changed the username and also the password. So first of all, the password is now 2020 because they changed it here. And also it's no longer Oracle, it's MSSQL, right? And yeah, this is a bit guessy, but I think it's not badly done. And here it would be MSSQL, I guess. But this doesn't work either. So what else can we check? Well, you could try the SA account instead, because that one always exists on MSSQL. And here we have luck, we can actually connect to the database. So that's great. And one thing, or one way to execute commands on MSSQL is XP command shell. Let's see if it's enabled. And it actually is enabled. If it weren't, we could probably do it ourselves, so it wouldn't be a big problem either. But here we see the first strange thing. This is obviously no English Windows, this is Spanish or something like that. So some things are named weirdly if you don't speak Spanish. And we have a lot of privileges actually. And when I got the root blood on this box, I actually just exploited the SeImpersonate privileges with PrinceProofer. But at the end of the video, we will explore these privileges a bit more in depth, because there are more possibilities to actually get root here without doing all the work. One thing to keep in mind is that we still have these firewall restrictions, so even though it would be nice to get a proper reverse shell here, we can't really do it because the firewall doesn't let us, and we don't have the permissions to change any of the rules. So let's continue enumerating through this SQL shell here, and first of all, we're going to list the users directory to see what else we have here. And there are a couple of users. We saw some of them already mentioned, but not all of them. And actually, you can see that this SVC MSSQL user actually exists, just couldn't connect with the credentials. So maybe this is a real user account, but it's just not able to log into MSSQL. And our user, of course, isn't allowed to list the home directory of this user, but maybe we can use PowerShell to switch users. When we first did the box, there's actually something InfoSec came up with, so thank you. We're basically just using PowerShell here to use invoke command with the credential flag, so we can use the credential from the other user. And we are just using the password we used earlier, but in this case, for the SVC MSSQL user, right? So we get the space 64 here, and just have to execute it now, right? So copy that here, XP command shell PowerShell.enc, which is for encoded command, and then we should actually be able to list the directory. Sometimes it's a bit broken here. Connect again. Now it's hanging. This means it's actually doing something. Sometimes this connection is just a bit unstable. And also these commands take a lot of time. I don't know what it is. And here we finally got some output. It really took a few minutes here. But we actually got the directory listing. So it's just super slow. And this way we can basically enumerate the whole home directory of this user. And eventually you will find that on the desktop, there's an interesting file. So let's list the desktop here. I already know that, but yeah, I don't want to show full enumeration when it takes so long. So let's just list the desktop here. Here we go. We can see on our desktop there's a node, and there's also credentials.kdbx, which is basically a Keepass file. So let's download that file. And we're going to download it like that. We're using certutil to encode it as base 64, and then we are saving it in a temp directory here. We still have to create that one. So let's do that first. So this was fairly fast. Check if it really was created. Don't trust this box. But here we go, it exists. So let's run that. That probably means it worked. I don't know. Here we go, a file exists. Just type to read it, and then we can just copy all the base 64 here. Let's clean that up a bit. We have to move the new lines, basically. And we got our file here. So this should have worked. Now let's use the Keepass CLI to access it. Then we do open credentials.kdbx, and we need a password, which we don't have. Luckily, that's a way to obtain it. We can actually crack it with John. To do so, we need the conversion script. Let's see where it was. Keepass to John. Yeah, that looks good. And we want to output to key hash, and we got it. Let's crack that one. And here we go. We get a password, which is Mahal Gita or something like that. So let's go to kpcli again, open the file, let's enter this password. And now we can navigate this. There's a database. There's several folders here. Let's go to Windows, SSH. This looks interesting. Let's show the entry. And here we got an SSH password, it seems. This is nice. Let's try that out. And this worked. We are logged in. Yeah, it's Windows. Let's go to desktop. And here we got our user.txt. So one thing I always like to do is I like to run the Pivotapi script by itment. So just use scp here to get it copied over. It should be here on the desktop. Right, let's go into PowerShell. And let's run that. There's an unusual service here called repair AD, but it's on the admin home folder, so can't probably do anything there. One interesting thing is also that this isn't called administrator, it's called administrador. So we have to keep that in mind later on. There's labs here. It's also pretty interesting. Nothing interesting in the processes. You can see some stored credentials, but probably nothing interesting. There's a console history here, which normally would be interesting, but in this case, it's only 3 lines. And this will be the commands we just executed, so it wouldn't help us. Yeah, but other than that, there isn't really anything crazy interesting. So since this is a domain, one other thing we of course should do is to upload charpound and just enumerate the domain. So let's do that. Just going to use scp here again. So it should be here. So let's run that. So we want to use all collection methods plus GPO local group because that one's not included in all. And here we got our data. Just use scp here again. It's telling us the file name here. To copy it to the local directory. All right, and now we have to go into Bloodhound to actually analyze that. So let's upload the file here. Go, it's all finished. And we got a couple of users, groups, and so on. Let's look for our user first. It's telling us we have a reachable high value target. Usually it's a good sign. And here it's telling us something interesting as well. We have generic all privileges on another user. And this user is actually part of the WinRM group, which can pierce remote into the domain controller. It's always treating this pierce remote as a really dangerous thing, and in reality it also is. But on HackTheBox, it's kind of normal that you have a low-pref user on a DC, so that's not too crazy, I guess. But the generic all will be here for a reason, so we're going to use that. Let's see how we can exploit that one. We can manipulate the target object how we wish. Modify properties to perform a targeted Kerberoast attack or reset the password. So we could try to get the current password or reset it. So I guess it would be interesting before we try to reset it to obtain the current one in case it's reused or something like that. One other thing we can do is we can mark our user as owned here and then just use this default search here. Shortest path from own principles. And it will show us the same path. It's just trying to get to a high value target starting from the user. We marked this owned here, right? So it's exactly the same output. So now let's execute the attack. We are going to scp power view over to the box. Then we do import module. And we want to set the domain object, which is basically just copy pasted from Bloodhound. Just replace the identity here and also the service principal name, and please subscribe. So now we have an SPN set to this object. The reason we set the SPN is because without one, you can't Kerberoast the user, right? All right, let's try to verify that. Now there should be an SPN somewhere. Yeah, here we can see it, service principal name, please subscribe. So that's good. Now we should be able to Kerberoast it. And we can actually do that via PowerView as well, instead of using inpacket, just by using getDomain SPN ticket. Then we give it the SPN, and we get us here indeed, right? If you compare, this is also what Bloodhound is telling you to do here. Basically the exact same steps. So let's copy that hash. We need to clean it up a bit, so let's replace these indentions. And we're also going to remove all line breaks. So this looks good, I think. Let's call that Kerb1. Let's try to crack that. And we can indeed crack it, which is lucky. This isn't always the case. If it wouldn't have worked, we could have tried to reset the password. So before we try to log in or anything, let's see what this user can actually do. Group memberships. We are in, I guess, domain users or something like that, and in the WinRM group. So now if we would forward the port, we could probably WinRM. Not sure if that helps us. Let's see if there's anything else. We aren't any admin. We have object control. This is interesting. This user actually has generic all as well. Remember, this is the privilege we just exploited, and here we have it again. So this user has generic all on 2 other users. So we can just repeat the exact same steps again, but from this user. So in order to do that, we are going to SSH here again, but this time we are setting up a forward for the WinRM port. Now what we need as well is a hosts entry for Pivotapi, because it wants the host name here and not some IP. And then you can just use it like normal, like that. So let's connect here. And this worked. See if there's anything interesting here. Doesn't seem like it. We saw already that we have the generic all privilege, so we have to just do the same steps we did earlier again, this time from this WinRM session here. So let's upload PowerView or the module, and I'm just going to copy paste the same commands here again. Set domain object, we give it an SPN of smash the like button. Now we verify that the SPN was set. And we can do the Kerberoasting again. But it's giving us an error here. And the reason we get this error is because we're doing it from this WinRM session, which is session 0. And there are several restrictions on that one. But it isn't really a problem because we can also do it from here, right? Now it's just a Kerberoasting step left. So there isn't really a reason to do it as this Dr. Zeus user. So let's import PowerView here as well. And now we run the command again, but from the SSH shell. And here we get the hash. So let's save that as well. Gotta do the cleanup again. All right, going to exit that shell. And now we should be able to crack the second one too. And it's actually the exact same password. That wasn't a waste of time at all. So let's try to connect with this user via WinRM. And this works as well. Nothing too interesting yet, but if we go back to C here, there's a developers folder, and these two are developers. So let's get in here. Maybe there's something in the Superfume user. Nope. Maybe in Jari. Yes. There's a C# program here. Let's look at that. There's the RC4 encryption scheme here. seems like it's encrypting a password, but in this C# file we have here, there's no entry in keys, so we can't really see the password, right? And this Jari, I assume, is another user. I forgot already. Let's check. Yes, it's another user on the box. Just mark this one as owned. Let's see if he has anything interesting. Oh, I can also PS remote into the DC. That's fair. But actually, we want to know if he has any special permissions, right? Outbound control lights are always interesting. Okay, it seems that this user has ForceChangePassword on yet some other users. So let's get not ahead of ourselves and try to get Jari first. So I copied over this binary to my Windows VM as well, and we're going to use the nspy to analyze it, which is really great against C# programs. So let's open that one. And here we can see the decompiled code, which is for C#, pretty much just the original code. So it seems this is some kind of key that is actually used to decrypt this byte array here. And the result of this should be the actual password for the user, I guess. So let's put a breakpoint here. You can see that this array is actually not even used here, so it seems to be broken. But let's just run it and debug it. So our breakpoint was hit. I guess we have to step one further. And now we should be able to get the contents of the byte array here. So let's make it a bit bigger. And this is probably the hex values of the actual password. So let's copy these. Just pasted them here and we can actually see the real password of the user, which is this one. Back to Bloodhound once more, we can see that this user has to change password privileges on two other users. Let's look at that one for now, because we see he is member of account operators, and this is pretty interesting. Like, this has a diamond here because that's a really important group. The account operators can actually add accounts to groups, so we would be able to add our account to an interesting group, and there's a whole lot here we could use, one of them being LAPS read or LAPS ADM. And these are the users that actually can read the LAPS passwords. And the LAPS password is basically the local admin password on this box, so it would be really cool to add our user to these groups, right? To do so, we first have to reset the password here, and then we have to use this user to add any user we already compromised to the LAPS group. So let's upload PowerView again. Then we are importing that. Now we're going to just use the credentials we have to make a credential object. We also have to make a convert to secure string object from the password we want to set on the new user, which is just password 1 to 3 in this case. And remember, this is all pretty much copy-pasted from Bloodhound, right? And then we use set domain user password on the user we want, which is Gipdian in this case. We set password 1 to 3, and we use the credential of this user we just got the password from. All right, it's saying it was successful, but let's verify by getting the user object. And password last set is pretty much right now, so this should have worked. So let's try to use the second step as well, which is adding a user of our choice to this group. We are going to create this secure password yet again, because this one we just set on Gipdian. Then we make a credential object for him, like that. And now we can use this credential object to add any user to the LAPS ADM group. In this case, I'm using this Superfume user. Could have also used Evasion or any we already compromised. And I'm adding it to the LAPS ADM group. So let's see if that works. So let's see, connect again with our SuperVume user. Let's actually run a whoami all. And we can see that we are indeed now in the LAPS ADM group. So this seems to have worked. One thing you can use to dump the LAPS password is LAPS Toolkit. I'll put a link in the blog post. For now, let's just upload that. Then we import the module. And finally run get labs computers. And this gives us the administrator password on the box, which is valid for like a day or something. So now we should be able to quit this, use the administrator user because it's Spanish and the password we just got. And we should be able to connect to the box. Yes, that worked. Let's go to the desktop. But there's no flag. Damn it. So let's go back. So it's probably one of the other users here, right? Actually, I think it's the CyberBugger user. Like that. Here we go. We got root.txt. So this is it for the, I guess, more or less intended path of the box. And now we're going to explore some unintended ways. Okay, so now we're going to start from this MSSQL shell again, and we're trying to look for some unintended ways. So first of all, let me run whoami all again. And we can see that we have multiple privileges here. One of them being SeImpersonate and one of them being SeManageVolume privilege. And these two I will show how to use for privilege escalation. When the box was released, SeImpersonate was also enabled and the print spooler service was running, so you could use the print spoofer exploit by Itman to get a system shell real quick. But shortly after that, I reported it, and this was basically fixed by disabling the print spooler service. So now that specific path is no longer valid, but there are other ways to exploit SeImpersonate as well, and I'm going to show that. One way is Rogue Potato here, which is an exploit by Splinter Code and Decoder. And basically, the requirement to execute that is that you have to reach your own box on port 135. So in this case, we can't use it because the firewall is preventing that, and we don't really have a means of changing that. But there's luckily another potato we can use here, which is the EFS potato. And this one is basically using the MS EFS RPC API to solicit authentication from the machine account. And since we have SeImpersonate, we can impersonate the machine account and escalate privileges that way. And the technique used here is basically what was also used in Petit Potem, I think. It's one of the vectors. Okay, so you basically have the code here. Can compile it like an instructions here, and then you get a binary. So I already copied it over. You don't have Winarama SSH at this point, so to copy it over without having that, you would have to, I guess, basic C4 encode the file and use certutil to decode it, right? So let's see. I have the file here in ctemp, and I'm just going to run it now with whoami as an argument. So the argument is just the command you want to run. And here we go. We are system. So now you could potentially read the flag or disable the firewall and get a shell or something like that, right? Okay, so that's it for the SeImpersonate privilege, but there was also the SeManageVolume privilege, which we are going to have a look at now. And we can find some description here from Microsoft. This privilege is used to perform volume maintenance tasks, and basically it gives you access to disk. And this is, of course, very interesting for us. Here it's already saying when extended files are opened, the user might be able to read or modify the acquired data. And it's even giving a warning somewhere down here, I think. Yes, a user who has this privilege could delete a volume, modify data, user rights assignment, privilege escalation. So this is already something that is known. But in this case, we have the privilege, so we can export it, I guess. It's not so easy to find much information about that. But there's one tweet here, which is pretty interesting, which is this one here. And it's describing how we can use it to escalate our privileges, right? We have to enable the privilege, of course, that is a given. Then we have to create this handle and send this fsctl-sd global change. This sounds complicated. We don't really know how to do that. But luckily, he has a GitHub repository here, which has some example code. So there's an implementation here that actually does it. And I wrapped that in my own exploit just to add the privilege enabling and also changing some requirements. So you can get it from my repository as well. I've linked the original here too. Let's see. It's basically very similar, right? We have the enabling of the privilege, then we have most of the code from the example. And then in the end, it's just telling us permission change worked or didn't work. And what this basically does is give us full read and write access over every file on the system. So you can imagine it's easy to like read the flag, or you could also write a DLL. And I wrote it in the README, and here as well, you could, for example, place this time zone related DLL here, call system info, and then it will be executed. So that's one way you can get a shell here. So let's try that. So again, I'm just going to SCP the file over to save some time. See if it worked. Yep, our file is here. And just to see the difference, I tried to list the administrator directory, but of course it's not working, right? We are not administrator. Yeah, we can't read it. So what happens if we run the exploit? Let's run that. Says success, the permission should be changed. So let's try that command again. And you can see now we can actually list the directory. So we got full read and write access over the disk. This is really good. And now we should be able to read the root flag this way as well. Here we go. So that's two alternative ways to root this box that are still unpatched, still possible. Yeah, and that's it from my side. If you liked the video, please subscribe, click the like button, and see you next time.